Right now, in the middle of the North Atlantic, a current that has run like clockwork for 12,000 years is wobbling in a way scientists cannot fully explain. At the same time, over North America, meteorologists are watching the jet stream buckle into a shape so fragmented it's triggering simultaneous heat waves and flash floods thousands of kilometers apart. Over Antarctica, the stratosphere just did something it has never done in 44 years of satellite records. Twice in one season. And deep beneath Canada, Earth's magnetic North Pole has been sprinting toward Siberia at speeds nobody predicted, before suddenly slamming the brakes in a way one geophysicist called the largest deceleration ever recorded. 4 systems, 4 continents. Roughly the same window of time. And in every single case, the scientists studying them are landing on the same uneasy phrase. We don't fully understand why. So is this a coincidence, or is there a bigger pattern connecting all of it? Let's actually go through the real data, because the true answer is more interesting, and more useful, than any single scary headline. Let's start in the ocean, because this is the story most people already have half wrong. Headlines love to claim the Gulf Stream is shutting down and that Europe is about to freeze. But satellite infrared imaging shows the Gulf Stream itself sits off the eastern coast of the United States, not Europe. It's a wind-driven current, roughly 50 to 150 kilometers wide, powered by the westerlies and Earth's rotation. What actually reaches European shores is a different system, the North Atlantic Current, which the Gulf Stream feeds into along with other currents like the Canary Current off West Africa. Both are part of something far larger, the Atlantic Meridional Overturning Circulation, or AMOC, which moves roughly 17 million cubic meters of water per second northward, according to oceanographic monitoring networks like Rapid AMOC. Unlike the Gulf Stream, AMOC isn't driven by wind. It runs on thermohaline circulation. Warm, salty water travels north, cools, sinks because of its density, and flows back south at depth. Multiple studies published over the past 5 years, including modeling work referenced by the EPCC, flag a measurable freshening of the North Atlantic, largely from accelerated Greenland ice melt, now estimated at over 270 billion tons per year, according to NASA's GRACE satellite data. That fresh water dilutes surface salinity, and if it dilutes it enough, less water sinks, and the AMOC engine slows. Whether that slowdown becomes a full stall is genuinely contested, but geophysicist Tim Palmer has pointed out something most coverage ignores. A weaker AMOC wouldn't switch the Gulf Stream off, it would push it slightly south, which could actually cool parts of northern Europe rather than simply ending it. Now move from ocean to sky, because the jet stream has been behaving just as strangely. This band of high-altitude wind exists because the equator heats up far more than the poles, creating pressure differences that, combined with the Coriolis effect, generate a fast west-to-east air current. Recently, meteorologists tracking North America's jet stream have documented it breaking into a fragmented, unusually wavy pattern, the kind of instability tied directly to the blocking weather systems responsible for heat waves that push temperatures in parts of northern Mexico close to 50 degrees Celsius during recent peak events, while other regions simultaneously flooded. Part of the cause is straightforward, as the Arctic warms faster than the tropics, a well-documented process called Arctic amplification. The temperature contrast driving the jet stream weakens, making it wobblier and more prone to getting stuck. But the more immediate trigger, according to NOAA's Climate Prediction Center, is El Niño, the periodic warming of the equatorial Pacific that shifts evaporation zones and reshapes pressure systems across the entire globe, distorting the jet stream on a much faster timescale than long-term warming alone. Then there's the polar vortex, and this is where 2024 delivered something genuinely unprecedented. Normally, a fast-moving ring of wind called the polar night jet keeps the extremely cold polar vortex locked over the pole. When that wall weakens, cold air spills into lower latitudes, exactly what happened in December 2022, when Arctic air reached as far south as Florida. But the story that stunned scientists happened over Antarctica. On July 7, 2024, NASA researchers at the Goddard Space Flight Center recorded a sudden stratospheric warming event. Stratospheric temperatures normally hovering near -80 degrees Celsius spiked by 15 degrees Celsius in days. Then, on August 5th, it happened again, a second spike, this time 17 degrees Celsius. According to NASA scientists Lawrence Coy and Paul Newman, this was the earliest sudden stratospheric warming ever recorded in the region's 44-year satellite dataset, an event type that normally strikes the southern hemisphere only once every 5 years, compared to almost annually in the Arctic. The vortex, which normally spins at roughly 300 kilometers per hour in a tight circle around the South Pole, stretched into an elongated, weakened shape. One real, measurable consequence: the Antarctic ozone hole's formation was delayed that year, according to the Copernicus Atmosphere Monitoring Service, since the extreme cold needed to drive ozone-destroying chemical reactions simply wasn't there on schedule. Here's where we hit our core comparison. Because two sudden stratospheric warming events, one in the Arctic, one in the Antarctic, can look identical on paper and still produce wildly different outcomes. The Arctic version happens almost every winter, is comparatively mild, and mostly just disrupts regional weather for a few weeks. The Antarctic version in 2024 was rarer, more violent, and left scientists with a genuine mystery on their hands. NASA researchers pointed to the fifth warmest July on record for the region as a contributing factor, but there's also a compelling and still unproven theory tying it to a single earlier event: the underwater eruption of Hunga Tonga in January 2022. That eruption blasted an ash column an estimated 58 kilometers high, the highest ever observed from space, and injected an enormous quantity of water vapor into the stratosphere, water vapor that can seed the ice particle clouds tied to ozone-depleting chemical reactions. Same category of event, same hemisphere scale system, completely different scale of disruption. Which is the whole lesson here. Atmospheric systems don't respond uniformly, even to similar triggers. Now let's do the science break, because the magnetic field story needs one number put in real perspective. Earth's magnetic field is generated by the geodynamo, roughly 2,900 kilometers beneath your feet in the outer core, where a molten ocean of iron and nickel churns constantly, generating electric currents that in turn generate the magnetic field. Since its 1831 discovery by explorer James Clark Ross, the magnetic North Pole has drifted steadily. But starting in the 1990s, that drift accelerated from around 15 kilometers a year to a peak of roughly 55 kilometers a year, according to geophysicist William Brown of the British Geological Survey, a speed researchers have simply never observed before. Then, just as strangely, it slowed again, dropping to around 40 kilometers a year, which Brown has called the largest deceleration on record for the pole. To put 55 kilometers a year in perspective, that's the pole crossing roughly the width of a mid-sized city every single year, for years in a row. Geophysicist Kieran Beggan, also of the British Geological Survey, has noted the field's total strength has declined by roughly 9% over the past 2 centuries. Weakening unevenly, dropping over Canada while strengthening over Siberia, which is part of what's tugging the pole in that direction. This isn't cosmetic. In 2019, the World Magnetic Model, which underpins GPS and navigation systems worldwide, needed an emergency update years ahead of schedule because the pole had moved too far too fast for the old model to stay accurate. Brown has pointed out that navigating a straight line, the roughly 8,500 kilometers from South Africa to the UK, on an outdated model, could leave you around 150 kilometers off target by the end of the trip. Now, the conspiracy angle, because this always comes up whenever the magnetic field trends, is the wandering pole connected to the recent spike in earthquake activity people keep pointing to online. Based on the actual published science, no credible study has ever demonstrated that link. Earthquakes are caused by tectonic stress accumulating in Earth's crust, a shallow, mechanical process. The magnetic field is generated by fluid motion roughly 2,900 kilometers down, in the outer core, an entirely separate system, operating on an entirely different timescale. The field shifts gradually over years and decades. Earthquakes release stress in seconds. If there were a real driving relationship, you'd expect a measurable statistical correlation between magnetic fluctuations and seismic activity in the data, and there isn't one. Major earthquakes have struck throughout recorded history regardless of what the magnetic field happened to be doing at the time. As for the pole flip apocalypse theory, geomagnetic reversals are real and completely normal, occurring on average every few 100,000 years, with the last one roughly 780,000 years ago. But every credible model of the process, based on paleomagnetic rock records, shows reversals unfold gradually over thousands of years, not overnight and not as some single catastrophic event. Here's the genuinely interesting takeaway after going through all 4 of these systems properly. Yes, the data confirms something unusual is happening in the ocean, the jet stream, the polar vortex, and the magnetic field, all in roughly the same stretch of time. And that part is real and well documented. But unusual and worth watching closely is a very different claim from one single cause is driving everything. The honest scientific read right now is that these are four largely independent systems, each responding to its own mix of natural cycles: El Niño, volcanic aftershocks, core dynamics, layered with climate change amplifying some of them more than others. Not one coordinated signal. Four separate, enormously complex systems, all quietly reminding researchers how much is still genuinely unknown about how this planet works underneath the surface. So what do you actually do with this information? Here's a short, practical checklist. Follow primary sources directly. NOAA's Climate Prediction Center, NASA Goddard, and the British Geological Survey all publish free public updates, far more reliable than viral clips. If you live somewhere prone to sudden heat domes or cold snaps, keep a basic emergency kit ready year-round: water, a battery radio, and a few days of non-perishable food. Update your GPS-dependent devices regularly. The world magnetic model changes affect navigation accuracy over time. Don't panic share pole shift or magnetic earthquake claims. Check whether the source cites an actual named scientist or institution before believing it. If you're near coastal northern Europe or eastern North America, pay attention to seasonal forecast updates tied to AMOC and El Niño monitoring, since both influence regional storm and heat patterns years in advance. So here's my question for you. Have you personally noticed unusual weather where you live this year? A heat wave, a cold snap, a storm that didn't fit the season? Drop it in the comments. I genuinely want to see how widespread this feels on the ground. If this video actually helped you understand what's real and what's exaggerated in all this "Earth is warning us" coverage, hit like. Let's get this to 5,000 before the week is out, and subscribe if you want the next deep dive on what's actually happening beneath the headlines.